So the difficulty in completing these kinds of questions is that you're not told to use Pythagoras. You're given a scenario and the right angled triangle is hidden somewhere in the illustration. Here's a typical exam question. It's asking you if you had a rectangular television screen with a width of 45 centimetres and a height of 34 centimetres, could you work out the diagonal length? Well, they've drawn the illustration for you, and hopefully you can see that this illustration has actually drawn a right angled triangle. So the answer to this question is going to be found by using Pythagoras. We have the two shorter sides and we want to find the hypotenuse. So we are going to square our sides, and because we want to find the longest side, we're going to add the two sides together. 34 squared is 1,156 centimetres. 45 squared is 2,025. Add these two sums together and we get a total of 3,181. Our final step is to square root 3,181 and round our answer to three significant figures. 56.4 centimetres. Putting our answer on the answer line, we have a diagonal measure of 56.4. Here we have an isosceles triangle. The isosceles triangle has been split into two equal parts by the line AM, and that's created two back-to-back right-angled triangles. The information in the question shows us that the entire length of the BC, the baseline, is 8 centimetres. Having split that into two, each part of the base is 4 centimetres. In order to find out the line AM, we need to consider just one of the right-angled triangles. It has a base of 4 and a hypotenuse of 7, so we already have the longest side. We're going to calculate the one missing side as a shorter side by subtracting. So we will square the hypotenuse, we will square the base, subtract these two figures and square root our answer. 7 squared is 49. 4 squared is 16. 49 subtract 16 is 33. The square root of 33 will give us the side AM, and the question has specified us to round the answer to 2 decimal places, so just these two numbers after the decimal point. Make sure we put our answer on the answer line, and that will give us 3 marks. So in this exam question, Pythagoras is so well hidden, it's not even an illustration of a triangle, it's a trapezium. We're given various lengths of sides on the trapezium, and we're asked to calculate the base, the line BC. By looking at the trapezium, we can see if we drew a line parallel to the base, we'd create our own right-angled triangle. And the length of the base of our triangle is also the length of the base of our trapezium. If we have a side measure here of 3 and a total side measure here of 9, we can tell that this part of our side is also 3 centimetres. So the remainder of our side is going to be 9, take away 3. So the height of our triangle here is 6 centimetres. We already have the measurement for the hypotenuse as 10 centimetres, so we can calculate the base by doing Pythagoras and subtracting. Square the hypotenuse, square the shorter side, and subtract the numbers. We might not even need a calculator for this one. 10 squared is 100. 6 squared is 36. If we take 36 from 100, we get the answer 64. If we square root 64, you might recognise that the square root of 64 is actually a whole number. It's 8. So the length of the base of our triangle is 8 centimetres, and as it's the same length as the base of our trapezium, we know the length of BC is 8 centimetres. And you could easily find that calculation on a non-calculator exam paper. You have a number of exam type questions you can now try in your workbook.